Welcome, dear students. This is the second revision for secondary certificate for physics. I want to give you some advice about how to solve the physics in exams. We have to read the question carefully, and also in the problem we must write the given in the right side of the paper, and we have to write the connection between the rules or the connection between the physical quantities which you found in the rule. And I want to tell you that we must careful for keeping the rules and the physical meaning of the rule, and also graphical representation between the physical quantities, and we have to be comfortable before the exams. The first, we have to solve some problem which are received from some student. This is a problem which are, first, from the circuit shown in the figure. We have three resistors in parallel. The first 20 ohm and 30 ohm and 60 ohm connected to two parallel resistance. The first 6 ohm and 12 ohm, and they are connected to battery. The given are the potential difference across 6 ohm, potential difference across 6 ohm is 48 volt. Find total current and potential difference across 20 ohm. First, we know that in any two parallel resistance, the potential difference in them are equal. So the potential difference in 6 ohm is equal to the potential difference in 12 ohm. So V equals I1 R1. Then 48 equals I1 times 6. Then I1 equal 8 ampere. Then we can find also the current passing in 12 ohm. V equals I2 R, which is equal to 12 times I2 equals 48. Then I2 equals 4. Then total current equal 4 times 8 equal 12 ampere. If we want to find the potential difference across 20 ohm, we find the total resistance. Then 1 over R total equals 1 over 20 plus 1 over 30 plus 1 over 60, which is equal to 1 over R equal 1 over 10. Then R equals 10 ohm. Then the potential difference V equals I times R. We know that the current equal 12 ampere and the resistance equal 10. Then the potential difference is equal to 120 volt. This is the first problem. We can find the second problem. Second problem, which is a battery of EMF 8 volt. A battery of EMF 8 volt and internal resistance equals 1 ohm. and is connected to wire of length 0.1 meter and area is 3 times 10 power negative 8 meter square, and its specific resistance, which is rho, equal to 4.5 times 10 power negative 6 ohm meter. Find the flux density. Find flux density, which is equal to, which is noted by B, at a point at distance equals 0.2 meter from the wire, given mu equals 4 by times 10 power negative 7 Weber per ampere meter. So we must find the magnetic flux density. First, if we want to find the magnetic flux density for a straight wire, B equals mu I over 2 by D. So we must find the current intensity and the distance. The distance is given. So we must given the current intensity. Rho equals R A over L. Then rho equal 4.5 times 10 power negative 6 equals R times 3 times 10 power negative 8 over 0.15. Then R equal 15 ohm. Then we find the current intensity. I equals VB over R plus R. Then I equal VB equal 8 over 15 plus 1, which is equal to 8 over 16, which is equal to half ampere. Then we find the magnetic flux density. B equals mu I over 2 by D, which is equal 5 times 10 power negative 7 Weber per meter square or Tesla. Second problem, which is from the circuit shown, find current passing in 6 ohm. We draw the circuit, 6 ohm and 4 resistance, first 8 and 4 and 2 and 4. We find that the battery is connected to rheostat and VB equals 12 volt and R equals 1 ohm. We notice that the current passing equals 1 ampere. Find the resistance must be taken from the rheostat. Resistance must be taken from rheostat. Find resistance from rheostat. First, we find the total resistance. R equals 12 times 6 over 12 plus 6, which is equal to 72 divided 18 equals 4. And then our total equals 4 plus 6 equal 10, and the other resistors, which is equal to 10, equal 10. So our equivalent equal to 10 times 10 over 10 plus 10, which is equal to 5 ohm. We want to find the resistance which is taken from the rheostat. We apply the rule I equals VB over R plus R. We know that the current intensity equals 1 ampere, VB equals 12 volt, R equals 1, and 5 plus R. These values which are taken from the rheostat. Then R equal 12 minus 6, then R equal 6 ohm. And current passing in 6 ohm is half ampere. Let's move to another question. We can revise the other. We can tell you the problem again. From this circuit, 6 ohm and 4 ohm, 8 ohm, 2 ohm, and 4 ohm are connected to 10 ohm in parallel, and also rheostat and battery of EMF equals 12 volt, and the internal resistance equal 1 ohm. We want to find the resistance must be taken from the rheostat. First, we must get the total resistance. R total equal 12 times 6 over 12 plus 6, which is equal to 4. And R equal 4 plus 6 equal 10 ohm. 10 ohm is connected to the other 10 ohm in parallel, so R total, which is equal to 5 ohm. The rule is R total equal product over sum R1 R2 over R1 plus R2. So the total resistance equal 5 ohm. So we must find the resistance must be taken from the rheostat. I equal VP over R plus R. Then 1 ampere equal 12 over 5 plus 1 plus R. Then R equal 6 ohm. Current passing in 6 ohm is half ampere. Let's move to another problem, which is if kinetic energy of emitted electron from surface of metal, is 1.6 times 10 power negative 19 joule. If the frequency of incident light is 7.5 times 10 power negative power 14 hertz. Find the work function. Find work function given H equal 6.6 times 10 power negative 34 joule second. We know that when the light falls on the surface of metal, we find that electrons are emitted. So the frequency of this light must be greater than the critical frequency. The rule which is used to find the work function, which is H nu, this is the energy of falling light, which is equal to work function plus half m v squared, which is kinetic energy of electron. H nu 6.60 times 10 power negative power 14 equals EW, which is work function, plus half mv squared, which is equal to kinetic energy, which is equal to 1.6 times 10 power negative 19. Then work function equal 6.6 times 10 power negative 14 times frequency, which is equal to 7.5 times 10 power 14. Again, we can substitute again. H nu equal EW plus kinetic energy. H 6.6 times 10 power 34 times nu 5.6 7.5 times 10 power 14, which is equal to EW, which is the work function, plus kinetic energy, which is 1.6 times 10 power negative 19. Then work function equal 6.6 times 10 power negative 34 times 7.5 times 10 power 14 minus 1.6 times 10 power negative 19, which is equal to work function. We know that work function EW equal H nu C, which is called critical frequency. So we can find the critical frequency, then nu C equals EW over H. This is a problem. We can, by using calculator, we find the final answer for the work function. Let's move to another problem. We know some units and this unit have equivalent unit. So we first the unit of pressure. It is unit Newton per meter square, or can be called Pascal, or joule per meter cube, or kilogram meter negative 1 second negative 2. This is the unit of pressure. Unit of pressure is equivalent to Newton per meter square, which is Pascal, which is joule per meter cube, which is equivalent to kilogram meter negative 1 second negative 2. Current intensity, coulomb per second, or ampere. Potential difference, which is volt, joule per coulomb. So volt equivalent to joule per coulomb. Power equivalent to its unit watt, which is equivalent to joule per second. Another unit, self-induction, which is denoted by L. It is unit Henry or volt second per ampere or ohm second. Also mutual induction, same unit, Henry volt second per ampere or ohm second. Unit also for potential difference, volt, which is potential difference, it is unit, volt, or which is equal to Weber, which is equal joule per second. Also, we know that from Faraday's law, EMF equals N delta phi over delta T. So EMF unit, its unit is volt times second is equivalent to Weber. Weber is the unit of flux only, magnetic flux. So magnetic flux its unit is Weber or volt second. Another unit, mass flow rate. Mass flow rate, kilogram per second. Volume flow rate, meter cube per second. Density, kilogram per meter cube. Velocity, meter per second or meter hertz, and the unit and its equivalent. Also viscosity, coefficient of viscosity, which is denoted by eta, which is kilogram meter -1 second -1, which is denoted by Pascal second, or Newton second per meter square. Newton second per meter square. And after this, unit of coefficient of volume expansion, which is denoted by alpha, which is its value equal 1 over 273. It is unit Kelvin -1. Also beta 1 over 273. It is unit Kelvin -1 or Celsius -1 or Celsius -1. The rule which you can find the coefficient of volume expansion, alpha equals V100 minus V0 over 100 times V0. Beta equals B100 minus B0 over 100 times B0. Coefficient of volume expansion, it is the increase in unit volume for a gas if the temperature is raised by 1 degree or 1 Kelvin at constant pressure. And coefficient of pressure expansion, it is increase in unit pressure for a gas if the temperature is increased by 1 Kelvin or 1 Celsius at constant volume. These for all gases. Another question. The first, what's meant by? What is meant by? First, density. Density, it means mass per unit volume at constant temperature. Density neither depends on mass nor depends on volume, because density is a physical property. Density, physical property. And what's meant by? Coefficient of viscosity is equal to 0.028 Newton second per meter square. Eta, which is equal to coefficient of viscosity, which is equal to Newton second per meter square. It means coefficient of viscosity, which is equal to 0.028 Newton second, is equal to tangential force acting on unit area to produce unit change in velocity between two layers of 1 meter apart. Coefficient of viscosity, which is equal to tangential force acting on unit area to produce a unit change in velocity between two layers of 1 meter apart. And after this, what's meant by the periodic time is equal to 1 over 50. T equals 1 over 50, which is periodic time. We know that the periodic time taken for one complete vibration or one complete oscillation. This is 1 over 50 is called periodic time. Then 1 over 50 is the time taken for one complete vibration. What's meant by frequency? Frequency, number of complete vibration or complete oscillation in 1 second. And another question, universal gas constant is equal to universal gas constant equals 8.31. That means the heat capacity of 1 mole are equal 8.31. It means heat capacity of 1 mole of a gas at NPT equals 8.31 joule per Kelvin. This is universal gas constant. And after this, from the figure, we want this lamp to be light. We have diode. This diode is PN junction. P type with N type are connected together and connected to lamp. We want connect with diode a battery in order to make the lamp will be light. So we must connect in forward connection. The meaning of forward connection, it means that B type is connected to positive pole and the N type is connected to negative pole. In this case, we find that the negative pole repel with electron and the positive pole repel with positive electrode. The hole will repel with positive electrode, so the current will pass and the lamp will light. This is forward connection. In case of forward connection, B type is connected to positive pole and N type is connected to negative pole, and the current will pass because the potential barrier will decrease and the current will be passed. Another question from Mustafa. This question is problem. The coil of alternating dynamo of dimension coil of AC dynamo is of dimension 5 times 10 centimeter. It consists of 420 turn. Is put in uniform magnetic field. In magnetic field of flux density 0.4 Tesla, and the plane of the coil will perpendicular to the field, and it rotates with rate 1000 cycle per minute. Find induced EMF. Find the induced EMF in each case. After quarter cycle, we know that EMF equals NAB omega sine theta. We know that theta is equal to 90. N 420 times area 5 times 10 power negative 4. Omega 2 by nu times sine 90. By using calculator, EMF equals 88 volt. And after this, find the EMF, when coil makes angle 30 from first position. EMF equals E maximum sine theta, then equal 88 times sine 30, which is equal to 44 volt. And if you want the average EMF, which is equal to N delta phi over delta t. We know that phi, which is equal to A times B, and the time, and we have number of turn. We can calculate the average EMF, which is equal to minus 56 volt. The sign negative, which denoted to, which is the Lenz's rule. Another question. What happens with mention reason of each of the following? Exceed the velocity of liquid flow at a definite limit value in symmetrical cross-sectional area. We know that in case of a steady flow, the condition of steady flow, the amount of liquid that enters the tube is equal to the amount of liquid that leaves the tube. The speed of the fluid does not change with time. But if the speed of the liquid increases at a certain limit over the critical velocity, the flow will be converted into turbulent flow. So in this case, the flow will be turbulent flow because the streamlines are connected to each other or intersect each other. Another question. The summation of two waves have nearly same frequency and have the same. Summation, it means superposing between two waves having the same nearly frequency and the same amplitude. This causes, which is called beats. Beats, it means superposing between two waves slightly different in frequency but having the same amplitude. This is called dips. Instant ray of light angle equal 0 on perpendicular side of isosceles triangle glass prism until go out to the other face. We draw this prism and this angle 45 and 45, and the ray falls perpendicular. It means the angle of incidence equals 0, and the critical angle will be more than the critical angle. The ray will be totally reflect, and the angle of emergence will be 0. Angle of emergence equal 0. And the other problem, we have a ray fall on equilateral triangular prism as shown in the figure. All the angles are equal. So A equal 60 degree. If the ray falls normally on one side and emerge tangent from the other side, from the opposite side, find phi 1, which is equal to angle of incidence, theta 1, angle of refraction, phi 2, angle of incidence in prism, theta 2, angle of emergence, and we want critical angle, phi critical, and also refractive index of prism. This ray falls normally on one side of triangular prism, equilateral. The first ray, the ray falls with angle equal 90, so the angle will be 0. This is the angle of incidence equals 0, because the ray falls perpendicular, and theta 1 equals 0. And also, phi 2 we make perpendicular, and this angle equal 30, and phi 2 is equal to 60. Theta 2 equal 90, and phi critical, which is equal to 60, because the ray emerged tangentially, it refracts with angle equal 90, and we want to find the refractive index. N equals 1 over sine phi critical. So N equals 1 over sine phi critical or 1 over sine 60. We can find also alpha. Alpha equal 2 phi 1 plus theta 2 minus A, then alpha equal 30. This is about triangular prism. Another problem, Rutherford galvanometer of resistance 9 ohm. It measured a current of maximum current is equal to 100 milliampere, and this is the current passing through the galvanometer, and the galvanometer, and also 9 ohm and milliampere. Find the value of resistance. Find value of resistance to be connected in parallel, to be connected in parallel with the coil, to measure a current of maximum current of parallel with the coil, or convert it to the ammeter to measure maximum current of maximum value of 1 ampere. 1 ampere. So we must connect with this shunt. The law of shunt RS equal RG IG over I minus IG. Then we must find RS. RS equals RG 9 times 100 times 10 power negative 3 over I minus 100 times 10 power negative 3. Then RS equal, which is called shunt resistance, 1 ohm. What happens if we connect another 1 ohm with the same shunt to the current? So RS again equals RG IG over I minus IG. So the shunt will be two shunt, one of them, each one equals 1 ohm, so the total resistance will be 0.5 equals RG, which is equal to 5 times 10 power negative 100 times 10 power negative 3 over I minus 100 times 10 power negative 3. Then current will be 1.9 ampere. We notice that if the shunt, its resistance decreases, the current will increases. Another problem, what is, give reason for, decrease the wavelength accompanied by electron motion increasing electron momentum, by increasing electron momentum. We know that the d1 nature of electron, lambda, equals h over p. P, which is called momentum, and the h blank constant, m times v. Lambda equal h over p, or h over m times v. By increasing the momentum of the electron, the wavelength decreases, because the answer will, momentum is inverse proportion to wavelength according to the law. And another give reason, a wire carrying a current is placed in magnetic field, but it does not move. If we put a wire in magnetic field carrying a current, as shown in the figure, this is a wire, the wire placed perpendicular in magnetic field and between two poles of magnet, north and south, this is the field, and the current passing through the wire will move. In this case, the wire will move. But if the wire does not move, the wire will be parallel. So, in this case, the wire will be parallel to the field, so theta equal 0, since F equals LIB sine theta, and sine 0 equals 0, then the force equals 0, so the wire does not move. In this case, when the wire is placed perpendicular in the magnetic field and the carrying current, the wire will move, because due to the interference between the magnetic flux lines, which make a force that making the wire will move. And if the wire is placed parallel to the field, we know that there is no force and the wire does not move, because the angle is equal to 0, because the rule, which is F equal LIB sine theta, and sine 0 equals 0, so the force equals 0, so the wire does not move. And another give reason, the cathode ray deflect in magnetic and electric field. Cathode rays deflect in magnetic and electric field. We know that cathode rays are composed of electrons, and electrons have negative charge. Electron travel in straight lines, and also it carry negative charge. That's due to the charge will make the electron deflect in electric and magnetic field. We know that cathode rays having thermal effect and deflect in magnetic and electric field, because it carry negative charge. And another give reason, when light ray travel from medium to another, it will refract. Refraction of light due to the change of the velocity of light in different medium. When the light ray travels from one medium to another, light wave suffer deviation in its path due to the change in velocity, so the light ray will be refract. And there is difference between diffraction and refraction. Refraction, it happens between two media, but diffraction, it happens in one medium. The condition of refraction, the light ray travel from one place to another, or from one medium to another. But the condition of diffraction, the gap widths must be smaller than the wave length in order to obtain diffraction. Diffraction in sound wave is more clear or more obvious in sound, because the wavelength of sound is greater than the wavelength of light. The wavelength of light is very small, so the diffraction is not clear in case of light. And I want to make a comparison between interference, constructive interference, and destructive interference. Constructive interference and destructive interference. Constructive interference due to superposing between two waves having the same phase and also having the same amplitude. When crest meet crest and trough meet trough, it happens constructive interference, and the path difference will be m lambda. So in case of constructive interference, path difference equal m lambda, and in case of destructive interference, path difference equal m plus half time lambda. Also, how we can obtain standing wave? Standing wave due to superposing. Standing waves due to superposing between two identical waves having the same speed and amplitude but opposite in direction. Forming nodes and antinode as shown in the figure. This point is called node, and the other point is called antinode. Node position where amplitude equals 0, antinode position where amplitude equal maximum. We can find the wavelength of standing wave, lambda, which is equal to wavelength, equals 2L over N, where L represents length of string and N is number of segment. We know that if N equals 1, this is called fundamental tone. N equals 2 is called first over tone, and N equals 3, second over tone. The ratio between 1 and 2 and 3, the wavelengths in the first equal half lambda and 1.5 lambda. This is the standing wave due to superposing between two identical waves having the same speed and the same amplitude but opposite in direction. Let's move to another question. What is the indication of negative value in this rule? EMF equal negative 20 delta phi over delta t. This rule is called Faraday's law. Faraday's law, which is the average induced EMF is direct proportion to the rate of cutting the magnetic flux lines and inversely proportional to the time of cutting, and also directly proportional to number of turns. Negative sign, it represents Lenz's rule, which is direction of induced current opposes the change producing it. So negative sign in order to Lenz's rule. So EMF, average induced EMF, is equal to negative 20. It represents number of turns, delta phi over delta t, which is called rate of cutting the magnetic flux lines. Another question: what is the factors affecting, number one, magnetic force, number two, torque, number three, coefficient of viscosity The first, what are the factors affecting on the magnetic force? Let's back to the rule. We know that the force equals LIB sine theta. So the factor affecting the force or magnetic force is directly proportional to the length and directly proportional to the current intensity and directly proportional to the magnetic flux density, also directly proportional to the angle, which is sine theta. Torque, which is equal to BIAN, the torque affected by magnetic flux density, current intensity, the area of the coil, and the number of turns. Coefficient of viscosity, it depends on type of material and temperature. I will tell you again, the coefficient of viscosity depends on type of material and temperature. Also density depends on type of material and temperature. Also conductivity depends on type of material and temperature, and resistivity also depends on type of material and temperature, because all of them are considered physical property. And let's move to another question from Wafa. The question is, look at the figure. Galvanometer and connected to coil, and a magnet north and south, the direction of motion to downward. And this B and A. What is a kind of magnetic ball? What is a magnetic ball produced in B? We know that when the magnet gets close from the coil, the magnetic flux lines are cut by the coil, producing induced EMF, producing polarity in the coil. So the top of the coil will be north and the bottom of the coil will be south. So north and north opposes or make the movement of the magnet will be very hard. And so the answer is at A the north, at A the pole will north, and at B the pole is south. And if we put magnet in a coil, if you put soft iron in coil, so galvanometer will deflect more, because magnetic flux density of soft iron is very great. So magnetic permeability of soft iron is very great, so the deflection of the galvanometer will be more if we put a soft iron coil inside this coil. And at the end of our episode in revision of physics, thank you for hearing us, and we will continue in our revision. Thank you.
مدرستنا يا مدرستنا يا منورة والنور في بيتنا